Okay, in this activity, we have a couple problems here that just use the z-score formula in a couple different ways. So again, our z-score formula is the difference between our data value and the mean for the population divided by the standard deviation. Now keep in mind, the data value always comes first, and then you subtract from it the mean. Okay, for our number one, find the z-score for the variable x is equal to 81 in a distribution having a mu, or a mean, of 89 and sigma, or standard deviation, equal to 11.5. Now x equals 81, that's our data value. That comes first in our formula when we're setting this up. So we find the difference, divide by the standard deviation, we come up with a z-score of negative 0.7. So this is below the average, below the mean, so it's going to be to the left. When we draw our normal curve here, 89 is associated with a mu. 81, we're trying to identify what z-score that's associated with, and we just found that it's associated with a negative 0.7 z-score. For number two, find the variable x having a z-score of negative 1.38 in a distribution having mu, or mean, equal to 68.9 and sigma, or standard deviation, equal to 6.6. Now in this case, we're working backwards because we're trying to find our data value associated with a specific z-score. So I've set the initial problem up right here. We have negative 1.38, that's our z-score, is equal to our data value, which we're trying to solve for, minus our mu divided by the standard deviation. So we've got a fractional expression here, and we need to rid this right side of our equation of the denominator. We do that by multiplying this right side by the denominator, which is 6.6. That cancels that out. If I multiply the right side by 6.6, I need to multiply the left side by 6.6. So that brings us to our next step. We have negative 9.108 is equal to x minus 68.9. So again, working backwards, we're trying to isolate and get our variable by itself. We're going to add 68.9 to both sides. So we end up with 59.79 is our data value. So that the data value goes up here. It's associated with a z-score of negative 1.38. You can draw these a number of ways, but I like for students to draw the normal distribution where they have the curve, they have the data values above the curve, and have the z-scores below this horizontal line, because this horizontal line here is representing our z-scores. It's going to be really helpful if you try to stick with that, because otherwise you get numbers all over the place and it's hard for you to recognize what is being represented by an individual number. So for number three, find the z-score for the variable x is equal to 7.2 and a distribution having mu equal to 4.8 and sigma equal to 1.8. Plugging everything in here, we solve and we find that we have a positive z-score to the right of our mean, 1.33, and that would be associated with that data value of 7.8, which makes sense when we see everything along the curve. Okay, for number four, in a recent season, the New York Yankees scored 205 home runs and play in the American League, where the mean home runs was mu equal to 192 with a standard deviation of sigma equal to 36. The Mets hit 198 home runs and playing in the National League, where the mean home runs was 186.9 and a standard deviation of 28.7. They each play in a different league, so they each play with a different population. Our question is, which team had a better home run hitting season relative to their league? So this is our setup for the z-score for the Yankees. Again, the data value of their home runs comes first, and we subtract the mean for the American League, which is 192, divided by the standard deviation for the American League. So the Yankees was within the American League. That data will be used in this formula. We end up with a z-score of 0.36. We do the same thing for the Mets using the data for the National League. Again, the data value of 198 for the Mets comes first. We end up with a z-score of 0.39. We can see that the Mets had a higher z-score and therefore a better season relative to their own league. For number five, Nikki took National Standardized Test and scored 86 on each of them. Given the info regarding each test's distribution, in other words, given the mean and the standard deviation for each of these tests, we are calculating her z-scores for each test. In which subject was her standardized test score the highest relative to the population taking the tests? So we're plugging in our information for mu and sigma for the math z-score and come up with 1.03. So she was definitely above average. Science, we plug in all of our information. It calculates to be 0.81, again, above average. Literacy, we're plugging in all our information, and we come up with 1.21, which is the highest z-score, definitely far above average. We can conclude that she scored the highest z-score in literacy relative to the population of test takers.